Quantum dots are sometimes called artificial atoms. In 2023, the basic research in the area was awarded by a Nobel Prize. They are already used in some display technologies, and trust me, it's not just a marketing trick. Here is an image of an artificial atom. It's shaped like a perfect pyramid and just 100 atoms tall. The image was taken surely by a microscope. Greetings, my dear friends, my name is Alexander. I've been working with quantum dots for over 10 years, and in the following minutes you will definitely figure out what's going on. Artificial atom might sound like a clickbait, and it honestly is, but it's a fair clickbait. Even the Nobel Prize winner Juraj Alferov used that term, and it is quite accurate. What does artificial atom even mean? Which property of the real atom does the artificial one replicate? Let's take a look at the real atom first. It consists of the positively charged nucleus in the center and the negatively charged electrons around. These electrons are attracted to the nucleus in the electrostatic potential. We can also say that the electrons are localized in the electrostatic potential of the nucleus. In this potential, the electron form number of states, and the electron can only have energy corresponding to each level, and it cannot have any intermediate energy. It is the most important property of the quantum mechanics. Here is the simplest example of the atom. It's the hydrogen atom. It has the only one electron. The electron can occupy many possible states, though usually it's in the ground state. So how does the electron change the level? To jump to a high level or to drop to the lower level, the electron must gain or lose the certain amount of energy corresponding to the spacing between those two levels. And the electron usually gets or loses the energy in shape of photon. The energy of photon determines its wavelength, or in human terms, its color. So every time electron jumps between two levels, it absorbs or emits light of the specific color. You can check out the spectral series as Balmer or Paschen series. Each line in the spectral series corresponds to the transition of the electron between two specific energy levels. So, if we want to find a light source of a particular color, we just have to find an atom with the right pair of the energy levels. But it's not that simple. That's actually why we are moving from the real atoms to the artificial ones. First of all, not each line is a bright light source. Second, not all the atoms exist in shape of gases, and when we put atom into solids, the position of line changes. If we are searching for a couple of very specific energy levels, it could be hard to find. Even though if we found, the spectral line might be not bright enough for a practical use. There are actually many more disadvantages. For instance, we cannot integrate a single atom in the existing semiconductor electronics. But those two I mentioned above are the most critical for applications. And this brings us to artificial atoms, also known as quantum dots. So, what are the quantum dots? There are many types of quantum dots, but in general, the quantum dot is a system where an electron is confined in all three directions, so it cannot really propagate in any spatial direction like actually in atom. I personally work with the ones which look like pyramids I have already shown you, but the Nobel Prize was awarded for another type which looks like a low poly sphere. They both are made from semiconductor material but by a different technology. Now, how are they like artificial atoms? As I mentioned earlier, in atoms, the electrons are localized because of the electrostatic potential of the nucleus. In the semiconductor quantum dots, the electrons are localized also, but due to a property of the material. It's called band gap. I won't go too much to the details, but when you combine two different types of semiconductors, you can form a potential well. And according to the quantum mechanics, this well allows an electron to form a system of levels. And it works right just an atom. The transitions between those levels lead to a light emission of a specific color. That's why we call those quantum dots artificial atoms. They also have discrete set of levels, but to be honest, artificial atoms are even better light emitters than the regular atoms. Why, would you ask? And the answer is quite simple. They are simply bigger. For the efficient light emission, ideally, emitter must have a size around the size of the wavelength it emits. It works like just in antenna. The wavelength must match size of the antenna. In this case, antenna works the most efficiently. Quantum dots, taking into account refractive index, are just a few times smaller than the wavelength of the visible light. Meanwhile, if we consider an atom, its size already about 1,000 times smaller than the size of the wavelength, which makes them far less efficient light source. Another important point, you can't really change energy levels in the real atoms. Probably you can make tiny change with the electric or magnetic field, but it's quite minimal. In contrast, energy levels in the quantum dots depend on its size. This is called dimensional quantization, and the effect is a lot like a guitar string. When I press a string to make it shorter, it vibrates at the higher frequency. Shorter wavelengths, higher frequency, and because of Planck's relation, it has higher energy. That's actually all the idea of dimensional quantization. So, if we make quantum dots smaller, it emits bluer light. If we make it larger, it emits redder light. And we can tune the size pretty smoothly. It allows us to cover quite a broad range of the wavelengths. What's more, brightness of the quantum dot doesn't really depend on the size. And that's exactly used in the modern displays. We can produce quantum dots of a specific size to emit pure red or pure green light. No compromise there. To sum up, quantum dots are called artificial atoms because electrons localized into them also, samely as in real atoms, form a set of discrete levels of energy, and the electrons can jump between those levels and emit light of a specific color. Just like in real atoms. But in contrast to the real atoms, the process of light emission is more efficient. This feature is missing in the real atoms. That's why actually the artificial atoms deserved a Nobel Prize. Not exactly, it was given for fundamental research, but the value of the research, the outcome, is basically this one. If you like the real science with no simplification, please support my channel, like this video, write a comment and share the video with a friend of you who might enjoy this. I will be really thankful for help because for small growing channel, each contribution is really important. I also beg you to subscribe me because it's a growing channel and your each subscription is really sufficient for me. Thank you for watching and see you in the next videos.